Guten Morgen, servus die Wadeln. I have to apologize, I tried the dindle, the thread model didn't allow it. And yeah, being enablers of the future, I'm gonna take that over. So this is not a product that we're gonna talk about, but it's a concept. Actually, the current implementation is about 300 lines of vibe-coded bash. Okay, so much. But what is it about? First off, actually, as of a couple of days ago, I'm now, my name is Constanze, I'm a CNCF ambassador, I'm an independent researcher, and at this point, I really want to thank all the funding agencies that make independent research possible. And for the intro, you should know that that doctor is not a medical doctor, and you should not take medical advice from me. It'll make sense in a second. With me is...
Yes, hello everyone, my name is Vadim. I'm one of the maintainers of Harbor, and we want to bring SBOM into Harbor and also use it SBOM to ship our software to the user so that they have a confidence of software bill of behavior in their application.
All right, first, I need to understand a little bit the audience. Who here knows what SBOMs are with an M? That's, for the video, that's almost everybody. Who uses it? Oh, this is pretty good, pretty good. All right, let's, I brought you a container. And let me read you the container SBOM. So this stuff contains 1 milligram of dimethyl maleate, purified water, and a whole lot of chemistry that if I had the context knowledge, I'd probably be able to understand it. But since I'm not a pharmaceutical person, I actually do not know. So I'm not saying that this container bomb is useless. But now, if you wanted to use this medication and you wanted to know how it behaves in your body, if it's actually for you, or what this thing is supposed to be doing, is it a database or is it a tracing agent? What do? Lesen Sie die Packungsbeilage und ja, schlagen Sie Ihren Primary Care Engineer. So, and the question now, or the idea of an SBOM, a bill of behavior, is that analogy. So if we as software vendors, maintainers for hardware that we're going to hear in a second, can we distill the knowledge that we have when we ship a new release and we have a threat model, we test it on different systems? Can we, just like, you know, those medical pharmaceutical companies, they had to test to get an FDA approval and then just condense it into a little snippet. And here the question is...
I mean, we have to do it in a similar way that you have in a bypass settle, right? So there's a formal structure, how this thing is designed, right? So there's probably 1,000 documents how you write this bypass settle correctly. And we need to do the same for the software. So we need to have a format, a specification, a way how we can make this portable or usable for the users.
Exactly. And now let's talk how usually we understand when we have behavior now in software, how we currently traditionally approach this. Now, if you wanted to know that something in your runtime or your supply chain is going wrong, very generally, you need to get data out. We call it telemetry, observability, whatever you want. And then you've got a whole load of data and you need to interpret it, typically with rules. Now, who currently writes those rules? The platform engineer?
Nobody. No.
There we go. Exactly. Well, or yeah.
It's a reality. I mean, it's there, right? So the technology is there for a long time, but nobody using it, and there is a reason for that.
The reason for that is that you as the user, we don't have the 10 years of testing experience, plus each time with an update, we would have to update, retest those rules, guessing what maybe that vendor did, right? So who should be providing the rules?
The easiest way, if it's the vendor, so the one who built the software, because the one who built the software knows how the software should behave and what API calls are okay, what system calls are okay, what writing files is okay, that maybe modifying kind of a kernel config is not okay. Right, so like as a vendor, you should know your application the best, right? And you should transfer this knowledge to the user. so that the user can verify or can use this knowledge in a way.
Yeah, and this brings us to the question of why this probably wasn't done in the past. Does it transfer? So one thing is like tracing. I'm pretty sure that if you've used Linux and software engineering, you know how to trace a program because it's ancient. But now with the onset of eBPF, we had the idea, can we actually transfer those profiles in a generalized way? And this is in KubeCon London, what we then hacked up a prototype within a couple of hours. It essentially is like, well, if I change the kernel, if I change the Kubernetes, is it going to actually work? And the answer, which we're going to show you, is actually yes. And then at that point, we called it sort of transferable runtime profile. And you came up with the name that was SBOM, Bill of Behavior. And now let's look at actually technically what does the spec look, or one possible spec look like. So here, huge shout out to the Kubescape people. Matthias Berchi, as the principal maintainer, has given me last Tuesday the first new Kubescape that can use SBOMs now officially. And essentially you see here elements that the kernel can see of a software in a human readable, editable form. And if you've ever used an LSM, that is a Linux security module, ARMA SE Linux, and you, well, I'm not sure if you edited it by hand and it worked, applause. Yeah, I see some smiles, yeah. Now this is maybe a bit small, but on this stage I think it works actually. So you see this in Helm syntax, fake Helm syntax. You can literally edit these files. And what here we have, this is the vendor perspective. You would edit out what abstraction do I package such that my user can basically just use normal substitution when they receive this profile. Okay, but what does the user get out of this? So who here uses anomaly detection in their Kubernetes clusters? Okay, Dynatrace guys? And at least I cannot see anyone else. I would say runtime detection is a pretty advanced feature for most users.
It shows.
Yeah.
The hand shows it, yeah.
And what Kubescape gives you here is not just that we can trace the profile out and make it templatable, but also that we can load it, modify it in real time, and have something that in the kernel does a diff against this profile and gives you alerts without flooding it with noise. And that is actually on top of the fact that you get the updated rules with each update from the vendor. You also do as a user have that UX that currently I don't think any other please tell me, any other software can do, that you do get anomaly detection in runtime, plus human editable form. Let's do a little example here for Pixie. Pixie is a real-time debugger using eBPF. It is very, very powerful. You see here in the middle the capabilities that the Edge module uses to get the observability out. This is almost root level. And what I want you to notice is what I call the hiding surface reduction, not necessarily the attack surface. So we are alerting, and this profile each of these elements of Pixie can be profiled, and we can say, well, how much entries do we have per, let's say, network, file opens, executables, allowed syscalls, etc., and how much does it reduce it? So the important line here is if you look at the executable that is allowed to run without highest capabilities, we can identify that. So if you're running a container in an Ubuntu sort of base image, then you can say, well, not that entire container potential content can run with a high kappas, but only that one thing that's supposed to be. And for that, we can even do enforcing in the future. Whereas the alerting we can do on the rest of the profiles, such as the file opens and syscalls, which are generally much more volatile. This was a very, very technical slide. Now let's come back to what the vendor can actually add. So this was for the user. You get runtime anomaly detection out of the box. But now, so go back to the vendor. So we have, of course, a funding crisis now that with AI we heard. Now we still have to do normal software. So how can we increase actually software value when we ship it? And here the idea is that we give the user the ability to test their incident response based on the threat model that we as a maintainer foresee them having. Okay, that's a huge statement. Let's go into detail. Here you see a possible such a test. And now let's go to Harbor, because we've implemented it for Harbor. So basically you thought about the most critical attack scenarios that you have seen customers use, that you use going forward in the test suite, or that pen testers or the security audit of the CNCF basically gave you the feedback for. And now the idea is that we put it actually shippable into such a SBOM, right? So what are some critical threats that?
So from our particular perspective of Harbor, we as a vendor of Harbor, there are, like, let's say, the typical use cases that you know from normal application, like exploiting authorization flows, right? So you find a authorization flow and you exploit it and then use it, or you just hammer the instance with the artificial load that let it crash. Well, this is the usual suspects, right? But in Harbor use case, we have a few interesting use cases as well that we want to protect the users, because the consequences of these vulnerabilities can be quite severe, especially like the malicious artifact injection, right? So because we are shipping artifacts, we want to avoid that people, or that the attacker can inject something in the artifact, so the artifact gets shipped. You can overcome this with signatures. So if you're using artifact signatures, if you sign your artifacts, you sign them outside, and you have this trust there, you can potentially mitigate this use case, but not many do this, and there is still some possibilities where this can happen. And this is a threat risk that we would like to avoid, and we want to make sure that the users who are using Harbor can detect this type of vulnerability, or detect this type of attack if it happens. And the other one, which is also easy to accomplish and can have severe consequences, is the vulnerability evasion. So basically, what happens is, if you gain access to Harbor, you can tell that this image doesn't have this vulnerability, which it has, right? So you can avoid it, or you can tamper the database, so you can remove the entry from the database, so when it scans, it doesn't find it. Things like this. So you can do quite a lot of things if you want to go this route, and this could lead to the situation that you have vulnerable images and you don't know it, right? And then someone can exploit that, right, on via the other channel. And this is the, let's say, two Harbor-specific scenarios we would like to provide the user with capabilities of detecting them.
Right, because again, coming back to the hiding surface, if we use that SBOM, we can test not just that we can see it, but also if in our setup we cannot see it, then we know we're blind to this attack, which is also pretty important information to know, that I can test, oh, this attack, affects me as a threat model, but also I would not see it, meaning I need to do some other things, like maybe honey tokens that we're going to hear about later. And yeah, so now the question, originally actually when we thought about it, we thought we would attach an SBOM to OCI images, container images. But as we figured out that what actually matters and how we actually need to ship this is with the entire Helm package, or customize, whatever you want. Because the way that the components connect is actually the secret sauce. Do you use mount propagation? Are you going to use a certain way of exposing something with a sidecar, with a service mesh? These things are going to matter in your attack model. And this means we have to package an SBOM, not like an SBOM to the actual artifact itself, but we need to package it with the configuration default, with the same way of templating, overriding, such as you have in Helm overrides. So, yeah.
Yeah, that's because the SBOM has this dynamic nature, right? And the SBOM is static, right? So that's why we need to add this dynamism here as well. That's the main primary reason, yeah.
Yeah, and going back to the analogy with the medicine, right? I mean, oftentimes for you specifically, you might be allergic to something. You might be allergic to databases or Kafka. And so you need to...
Okay.
Yeah, and then you need to make your own choices, right? There's lots of legacy software out there where some best practices simply don't work. You need to override them, and this is why it doesn't go like signed as a hash to an image, but it comes as a best secure by default suggestion, condenses the knowledge of the vendor, but then gives you still the freedom of modifying it. Now, let's talk a little bit about what we currently tested on, and also, so I've been mentioning Kubescape. Kubescape is a wrapper of a lot of different programs, especially here we're using the thing that wraps Inspector Gadget. That it basically is a eBPF way of tracing out all these things we see in networks, syscalls, file opens, etc. However, there are other softwares in the CNCF ecosystem that could potentially also do it. Currently, we're probably thinking to include UpArmor next, which is actually an older, much older Linux core functionality. And the way we test this is I'm currently collecting a test bed, different types of setups of different clusters like GKE, AKS, but also local versions, older versions, OpenShifts, hardened things, Talos, etc., so that we get a good spread of this transferability. So we can't just test the knowledge of the maintainer, but also see what spread we have, what noise we generate in those signals. And this is actually what that looks like. So I would be going like Vadim, show me how to install Harbor, show me how to run a test suite. How we run it on a single cluster is basically a collaboration between a maintainer and myself. And then once we have it somewhat finished, we automate it. And then we let it run over a huge set of different clusters, configs, etc., and create first of a superset. So simply a superset of all the things. And now it matters if we're going to use this for supply chain or for runtime validation. These profiles can be hundreds of thousands of lines long, and they need to be diffed in memory. So that could be really important if you wanted to check if an installer does exactly what you think for supply chain validation. But now imagine at runtime, the performance overhead you would get by loading such maps into memory. This is why when we go now to the runtime alerting, we would generalize it. And here, again, when we create that Helm chart to abstract it,
we need to condense to the threat scenarios, preferably, right? Or to the, let's say, we have the outer surface where we want to protect from the usual suspects, and then we have the threat scenarios that we want to protect. And then we can reduce the complexity of the bit of profile to maybe a few hundred lines, where we say that this is essential, right? Because there's a lot of noise going on, and we as a vendor, we can basically tune this and reduce it from thousands of lines to a few hundred, and which makes it unusable to run in production.
And this is also why there's not a lot of coding actually necessary. It's mostly looking by eye, knowing your own software, and then literally putting a couple of asterisks or globs into the, or putting the abstraction, Helm overrides in the right place. Yeah, then you test it. I mean, this is GitHub. Essentially, you can check like how much deviation, how much noise do you expect on this particular setup. I know this is possibly not readable, but just in case you wanted to see this works. So this is all public, of course. We're not going to, because Andy asked us to speed up. So I'm going to show you where you would find a live demo. If you wanted to say like, Constanze, I don't believe you, I want to see this for myself, because lots of people actually like, this can't be that easy. So there is a link. If you have 10 minutes...
It's not visible.
Oh, it's not visible. Hi. Okay, then go back. So you would, there will be later a link, and you go to module 2 video. And that will take you 10 minutes to this live demo, which I will now skip, where you can verify that what I've just said, that you can both see a normal test, will not show any anomalies, and a make attack will, and then you can define, I want to see, let's say, 7 alerts. You can check so you see 7 alerts. And you compare like how it would work on a different kernel or Kubernetes distro. Yeah, so to save you some time, let's summarize the key point here. So tracing has always been possible, but we noticed that Linux security modules are typically not usable for, or seldomly used because of the user overhead. And the key idea is that we go from descriptive, means I record it as a user, not knowing how hardware works, and then maybe even if it's malicious, I record actually the malicious behavior and use it as my fingerprint. That's useful, right? Instead, we
change it to be descriptive.
Prescriptive.
Yes, sorry.
Yeah, prescription, exactly.
And so this becomes easier for the user to adopt and use actually and make sense out of it.
Because security doesn't scale. Typically, that's the problem. And here, the scale is achieved by packaging one thing to many and only doing small deltas. So that's the key idea. Again, the most of this is not a product, this is not a software, it is an attitude, so to say, and maybe will become a standard formalized into SPDX. Yeah, can you help? Can you help?
I hope so.
Yeah, so if you're a maintainer,
it's not difficult. Yeah. Well, the easiest way is you get the lab started. You can use the lab and you can find out how it is working. It takes like 10 minutes. It's really easy to use. You can get used to it. And if you have feedback on that feedback helps us improve the standard and the edge cases where things is not so obvious. And we need people to test their own software with that, right? So that you can profile your own software, get feedback, and this is like the next step. Like if you just use it and then try it out and then use it as well. Yeah. So this is the easiest way how you can help us.
Yeah.
Yourself.
Yeah, unless of course you're a maintainer and you'll do that tandem thing or a vendor of explaining to me how to run your tests properly, and then I can create a lighthouse project out of your software. Let's summarize. So software bill of behavior is SBOMs, but for runtime. The user gets anomaly detection out of the box. We get ideally scalability by transferring the knowledge of the vendor to the user, to go ideally even to incident response validation. Very important in some upcoming regulations, or now actually active with NIS2, CRA. If you've heard of those, you have crazy amounts of reaction times, like 4 hours to 24 hours, that you have to detect a breach. So this is where it was actually originally driven by. And yeah, the question whether it's going to be adopted is really, do we find enough vendors who will volunteer, help test it out and create the SPDX? But yeah, about in 2 weeks' time, I think Kubescape is going to officially release the version that can do it. The lab, you can star if you want to say like, hey, I support it generally, then we have a bit of feedback, it's motivating, like, yeah, please do that. And otherwise, I just want to thank those individuals. Because if you are an individual person going in, like, I want to do a new standard and I want to put that into 2028, a new regulation, you feel crazy. So if people gave me, those people that give me constructive feedback or gave me stories of your own life, thanks to you, because you encouraged me and us to actually start doing it and getting us as far as it is currently. So thank you.
Thank you.